This video is part 2 of our introduction to Ultimaker Cura, our slicing software. Today we'll be dealing with printer settings, things such as nozzle temperature, bed temperature, build plate adhesion and supports, plus a whole lot more. And here we go. Folks, welcome to part 2 of our introduction to Ultimaker Cura. Hopefully you watched part 1. If not, I recommend just taking a perusing at it, get your feet wet with that, because in part 1, that's what we did. We introduced ourselves to Ultimaker Cura, the navigation and importing a model. Now part 2, we're going to introduce the printer settings. So part 1 was very much Cura focused. We learned kind of how to navigate that software. Part 2 is going to be printer focused. We're going to go over settings that affect how our printer prints. Settings like temperature, build plate adhesion, supports. We're going to look at layer height. We're going to be using the preview menu, which is something we talked about in part 1, to kind of diagnose issues and demonstrate all these different printer settings. Now there's a lot of information to cover, so I'm going to leave it right here, and I'll see you on the other side after we get ready for part 2 of Introduction to Cura. So we've gone over some key features. We imported the model. We looked at what these different tabs up here can do for us. We've then gone into the model controls and looked into them. It's now time to look at the print settings, found all the way to the rightmost box. What I'm going to do is drop down this menu with this arrow down button. First menu I see is what's called a quick menu. This has highlighted a few of the settings we find in the full menu. I'm going to go there first. I click this custom button and it brings up my entire print settings menu. I'm going to drag this off just so we can get it in the middle of the screen, just to easier viewing pleasure. So right here, we have our different print settings. So these affect how our model will be sliced and how our printer affects that model. Right up at the top, we have a profile. Whenever you hear someone importing a new profile, that's what they're doing. When I click the drop down, I see some default profiles that have already been loaded in with this Ender 3 printer. They go from super quality, which is low, or I should say very small layer height, to low quality, which is a higher layer height. We're at the standard quality. It's a 0.2 millimeter layer height, and then some default values have been placed within all these different menus. For right now, we're going to work off this 0.2 standard profile. Every change we make will change this profile. Eventually, once we're finished, we can save that custom profile, and it will be found right under here. So when we come back, we can always load up this profile if we wanted to. Of course, every time we close Cura out, it does save all our settings. So when we reopen it, any changes we made to these print settings will have been saved without making its own profile. Each of these different sections is its own topic. It's almost like a big file cabinet, and when I open the drawer to that file cabinet, it shows me all the different settings that are contained therein. Right above here, this 3-lined section, if I click it, it shows me different options I have for how many settings I want to see in each dropdown. Currently, I have a custom selection selected. If I want to choose basic, you see right there, I lose some settings. What we're doing here is we're limiting the amount of settings we see. We're new to 3D printing. We have a lot going on, a lot of different things to learn. We don't necessarily need to be bombarded with all these different settings. Now, if I drop down walls, you'll see there's only 3 things for wall. Same thing with top and bottom. There's not a lot going on here. If I am to then choose off of basic onto something like all, you'll see that these settings are expanded tremendously. There are so many different settings now that I can affect and I can change to change our print. Now this is great. This shows us the ability we have to adjust all these minor settings in our print. But right now, because we're new or because we're just learning Cura, we don't need to see all these things. Let's get some prints under our belt. Let's get our prints up and running, our printer up and running. And then as we go further in our adventure with 3D printing, we can expand this menu and we can look at some more settings. So I'm actually going to click custom right now. I have customized some settings I think that are important. You might not be able to find all these settings under the basic icon. You might have to go down to advanced or expert to see some of these. That's fine. I just want you to know they exist. You don't necessarily need to change them like I am. I'm going to talk about them and you get to choose if you want to dive into those topics or not. So I'm going to select custom and we're going to start right here at quality. First thing I want to do is move this print settings box off to the side. This is where its default location is, so we can see our build plate. Now, right here in quality, the only major factors we affect are layer height and line width. And those factors are determined by the sizes of our nozzle. Now, by default, our Aquila, our Ender 3, our Uri 1 ER20 comes with a default nozzle size of 0.4 millimeters. That means the biggest layer height we can have is 0.32. That's 80% of our nozzle size, 0.32. I would say the standard layer height for that nozzle size is either 0.2 or 0.28. That's up to you. I generally use a layer height of 0.2 for all my models. Let's go and jump into this preview menu and just take a look exactly what all this means. So I have my sliced model. I've already brought it down the timeline. Let's bring it to the first layer. So when we talk about layer height, we're talking about the vertical height of our layer right there. That means this is 0.2 millimeters high. If I'm to go to the next layer, again, 0.2 millimeters high, so on and so forth. So I have 4 layers here, each 0.2 millimeters high. That means I have a 0.8 millimeter high model at this current stage. That's what layer height is. The bigger the layer height, for instance, if I was to make it 0.32 and then reslice it, you're going to notice that 2 things happen. One, my total layers decreases. It was at 100, now it's at 62, and the layers themselves are much bigger. That's exactly what layer height is. It changes the height, the amount of filament also that's extruded for each layer. So now this is a 0.32 layer. And the second layer, again, 0.32. So now with just 2 layers, I'm at a height of 0.64. So this will affect print quality in a number of ways. I recommend messing around with layer height. Once you get a feel for some printing, it's really cool what you can do and how you can affect your prints. Now, I like to always revert to 0.2 millimeters. I think it's a great mix of speed and quality. Now, line width. That is going to be the actual width of our line right here. So from left to right on this line, the width of it is 0.4. It matches our nozzle. Now, there's a lot to talk about when we talk about nozzle width or line width. I'm going to have a separate video that's dedicated only to nozzles and the really cool things that making minor tweaks to these things can offer. But for right now, let's keep our line width at what would be considered 100%, meaning it's the exact same size as our nozzle. So we'll keep it at 0.4. The next drop down we're going to look at is walls. Wall thickness, wall line count, and then Z-seam. So let's start with the wall line count. Again, we have our model. We're in the preview menu, and this is the first layer of a model. This green and this red denoted line is our wall. Those are our walls. They're also known as perimeters. You see they remain the same going throughout. We have a wall line count of 2, and here we have it. 1, 2. That's how many walls we have. And the wall thickness follows this directly. So we have a wall line count of 2. We know that our width is 0.4 for each line, meaning each wall is 0.4 millimeters thick. So if we were to have 2 of them, it would make it a thickness of 0.8. That's just the simple math that's there. But here's the cool thing. Let's say we wanted to increase our wall line count. We wanted to add strength to our model because that's what adding walls does. Let's say we made this a 4 wall line count. We notice now our wall thickness box is grayed out. Why is that? Because Cura is going to do that math for us. It means that this wall thickness number is no longer being operated upon. It's going to do its own math, and it's going to give us 4 walls, and whatever the wall thickness is, it's going to apply that. Let's reslice it. And this is all being done again in the preview menu. We look down here, and there we have 1, 2, 3, 4 walls. These green sections of wall denote inner walls, and this red section is an outer wall. And again, when we go to this tab, if we choose something like Expert or All, we have more options, and our options for inner and outer walls are things that we can modify. So now let's look at the second option in walls, Z-seam alignment. I'm going to zoom out and zoom around or rotate around to the back. We see this white dotted line running up the back of our print. Well, what this is all the starts of our outer wall. What happens when we start
a line here is, right before we started, filament was retracted. It is now being brought to this corner and started. That means filament is going to get extruded again. Now there may be some tweaking involved. If you are over extruding, you could have some lines or some bumps here, sometimes called zits. If you are under extruding, this might be shallow or caved in. But being able to see where our Z-seam is, that's what this is called, is a great way to diagnose problems like that within our print. Now, I chose to make this Z-seam right here in the corner. It's the best way to hide it, in my opinion. But if I were to go here to Z-seam alignment, I could change that. If I wanted to do random, for instance, which I hazard against, if I did random and I sliced it, you're going to notice those white dots that denote the Z-seam on our outer wall. They are all over the place. They are just scattered. That's because it is quite literally random. I find this to be not as appealing. You will have some marks on your outer wall no matter what. There's just no denying it, unfortunately. And when they're scattered all over like this, it kind of looks like imperfections in your print in a way that you didn't mean it to be. So I don't prefer it. I prefer it to be all in a straight line, and you can generally, using some of these modifications and settings, you can put that line to an area of your print that is concealed, or at least as concealed as it can be. The next section we have here is top bottom. And what this denotes is the top portions of our model. This yellow portion here and even this yellow portion down here is what's called a top. Now, it doesn't necessarily mean the topmost portion of our model. Top refers to any face of our model that is vertically up, just like this, that has nothing else printed above it. So even this section that's sunken in here, that is considered to be a top. What we have selected here is 4 layers for the top. Why is that? Well, 4 layers is the default, and it's a really good bridge between infill and top layer, because we want this top layer to be very smooth and printed as perfectly as it can be, because we're going to see it. Let's drop down 4 layers. I'm at 100 right now, which is the top. I'm going to click on the timeline bubble at top, and then I'm going to use my down arrow key to move down one step at a time, one layer. So I'm at 1, 2, 3, 4. That's how many top layers we have. When I go down one more layer, we're going to start seeing infill. One more layer, and there it is. So what top and bottom means is how many layers you want between the infill and the topmost part of your prints. So now, like I said, we also have this top portion down here. Now, while this isn't the topmost part vertically of our print, there's nothing else printed on top of this. So that would be a top or a ceiling. This is the first layer of it. 1, 2, 3, 4. After this, it's going to be infill. So the more top and bottom layers you have, the better those tops or those ceilings are going to look, because they have more scaffolding underneath it. So by the time I get to this 4th top layer, it's going to look very solid. It's not going to have any sag to it whatsoever. And the same thing goes for the bottom layers. This is how many layers we're going to print at the bottom before we start our infill. So this is the first layer, 1, 2, 3, 4. And now every layer thereafter is going to be infill. Now we've seen a lot of this. It's time to look at our infill dropdown. Infill doesn't have a lot going on in the custom options I've showed you. Again, we are in this preview menu so we can interact with our sliced model. That's why I love this preview menu. I'm going to drop down from layer 100 to somewhere around the middle, somewhere around 70, I guess. We know right here all this is infill. And our pattern is currently cubic. That is the default. If we were to hover over infill pattern, we'll get a small infographic, and it gives some of the positives of each of the different patterns. And you'll notice if I click this dropdown, there is a lot of different patterns. Let's try something like triangles. We select triangles, and every time we make a change to our model, we need to reslice it. And now this is what 20% triangles looks like. Very similar to cubic. Let's go to concentric. 20% concentric. This is what it looks like. Kind of cool. Now, all of these infill patterns offer different positives and different negatives, whether it's speed or strength. And of course, we can also change the density. Let's go back to cubic. And let's change it from, let's look what 20% looked like again. And then we'll change it to 40%. So that's 20% right here as it stands. Let's go to 40%, reslice it. And look at that. It is double the amount of infill we have. Now, a lot of people think the more infill you have, the more strength. Not necessarily true. if you were looking for added strength, wall line count. That's what we're looking for. Infill, adding infill will of course add some density to your models, but not necessarily the strength you're looking for. So this is 40%. Let's go somewhere as high as 80% and slice it. And we'll notice the infill pattern actually changed to lines. Why is that? It's because the infill is so dense that it's no longer going to be cubic. It's just literal straight lines across our model all the way up until we hit those top sections. Now, what I prefer to use is, for my default, 20% infill density, and I love this gyroid pattern. It's a great mix, again, like I said, of my quality. It's a great mix of speed and strength, and it looks really cool. It almost looks like the infill's dancing as we scroll through this timeline, but it's what I prefer to use. But again, read into some of the infill patterns and choose what you like. Up next on our drop-down menu, we have material. Now, when we drop down material, the two biggest ones, or two biggest settings in here, are print temperature and build plate temperature. So for our print temperature, our default is 200, and that's great for PLA. In general, PLA will take temperatures between 185 to around 210. It really depends on the filament type and the brand you're using. Under that, we have build plate temperature. I would say the average build plate temperature for PLA is somewhere between 50 and 60. So as a default, these numbers are great. What I highly recommend is doing some temperature tower, some different temperature tests, and checking what your specific filament needs in your specific printing environments. And when we want to change those, we come in here, we change the number. Let's say I want 205. I reslice it. And when it gets turned into G-code, that is now the new printing temperature. Of course, nothing will change visually on our model in the preview. This is simply something for our printer. Under that, we have flow. Now, I have a separate video that goes over E-step calibration, and that's a great calibration to make sure our tolerances, which is the accuracy of our printed lines or thickness of our printed lines, that's where we calibrate that. And flow is the final calibration of our E-step calibration. We will eventually come into this menu and we can adjust how the flow or how the filament is being extruded from our nozzle. And not only can we adjust it in a general sense, but we can go through here and we can start adjusting the flow in all these different macro senses. I want to show you this because it's something you should eventually get to. Maybe you don't need to do it right away. Again, get some prints in your arsenal, feel a little more comfortable. Then we can get back to calibrating our E-steps and then eventually using this section here and calibrating your flow. Underneath material is speed. This one is going to be sort of obvious. It's the print speed, the speed at which printing happens. Now, I'm only showing a few options. There are a litany of different options for different aspects of speed. Outer wall, inner wall, infill speed, everything like that. Right now, all you really should worry about is your basic printing speed. Default is 50 millimeters per second. I usually bring it down to 40 millimeters per second. It's just a great speed. We get quality prints. We don't lose that much time. And I usually like it with these sort of printers. Ender 3, Aquilas, Uri 1 ER 20s. I have a few of these menus or these settings here just to show you that there are some speed differences. So our top and our bottom speed, which we talked about, are these layers here, as well as our initial layer. We want them to go a little slower. The initial layer speed, we want to go lower because it's going to boost adhesion. If we start flying at 40 millimeters per second, which really isn't that fast, but it's faster than 20. If we start going a faster speed on our first layer, we might not get that good adhesion. So we slow it down, we do 20 millimeters per second. Same goes with the top and bottom speed. We want these tops and bottoms to look really nice, so we slow our speed down. Under speed, we have the drop down for travel, and this is where we deal with our retraction. Now, retraction is a necessary part of printing. It is when we remove or pull back the filament away from the nozzle. It clears pressure in the nozzle, and it prevents the nozzle from dripping or oozing excess filament. So we want to make sure that we have this enable retraction box checked. Under that is retraction distance. That's the actual distance the filament's going to be pulled away from the nozzle. Now, with these machines, Ender 3, Aquila, Uri 1 ER20, etc., the general default retraction is between 5.0 to 6.5. This profile comes with a 6.5 millimeter traction. That's a great start. We start from here, and the same goes with the speed. 25 millimeter per second retraction. Start there. do some retraction tests, see what works best for you. But these are a great base for you to start at. Under that, we have combing mode. So I wanted to go over this very quickly. What combing is, I'll bring this down here just to get our nozzle. So here's our nozzle. When it's performing travel moves, for instance, moves that don't require any extrusion, it will just travel in a straight line from A to where it needs to go next. That can sometimes lead to issues if there's nothing in the middle here. If it's a, for instance, a U-shaped piece, you can get some stringing when it moves in a straight line from the left side of your model to the right. So what we do is we do combing mode, not in skin. So this keeps our nozzle always within our printed model. So whenever it's moving, it's going to move above the infill of our models. So if there's any dripping or oozing or even stringing, it happens over the infill and it's hidden. Not in skin means it's not going to do it in any of these top layers. We don't necessarily want the nozzle accidentally dragging against these top skin layers and marring that surface. So we do it everywhere in the body of the model, but not on top. So that's a really good feature to have. And I believe by default, it is selected. Under that, we have cooling. For PLA, we want to enable print cooling and we want the fan speed to be 100%. These are default. This is a pretty obvious one. However, if you're using other materials like PETG, which is PETG, or ABS, those materials actually don't prefer a lot of cooling. And of course, when I talk about cooling, I'm talking about the fan on the side of our hot end that's blowing cold air down by our nozzle that's cooling that molten filament after it's extruded onto our model. So PETG and ABS don't necessarily want that. If they cool too rapidly, the layers cannot adhere. Those particular filaments, you might want to look into different cooling methods or speeds, but for PLA, we want print cooling to happen, and we want it to be 100%. Now, the next one we have here is support, and I'm actually going to bring in a new model for support. Let's get rid of this one, and this is a model that is from 3dmon.com. It's a great team from, I believe, the Czech Republic. They do a bunch of custom models, and this particular model is from Sylvie. She's a character from Loki, the Marvel series Loki. I don't know why I blanked on that for whatever reason. And this is a great example of why we need to support models. So I want to print this model just as is. If I were to do that, let's slice it. If I were to do that, all these red sections right here, they're telling me they need to be supported. The overhang on them is too high. So we have the slice model. I look at it in the preview. Everything looks fine, right? It looks like a printed model, but I can see right away this is printing in midair. If I was to try and print this model, but when the nozzle got to here, it's just printing on nothing. It's printing in air. There's nothing underneath this. It will fall. I'll get tremendous amount of stringing. This print will fail. So what do I need to do? I need to generate support. I click on generate support. That will now add support to any model I slice. And under here, we have a few other options. Support structure, normal or tree. Those are the only two options we have. For now, I have normal selected. And support placement, I have everywhere. These are the default values. What that means is this is going to put supports everywhere on a model, not just from the build plate up. So if there is any overhangs in the top portion of our model, it'll generate support within our model to then support that, which I don't really prefer because this can mar surfaces. But let's see if it does it here. I don't think we're going to need that. So it's sliced, it's supported, and look at that. Now we can print this model safely and not worry that any of these overhangs are going to print in thin air. We have this blue section here. That's all our printed supports. So as our model rises, support comes up, catches all those different areas that would normally print in thin air. It prints it on a very thin scaffolding and support. And now we can print this model perfectly without worrying about any sort of print failure. Well, we always have to worry about print failures, but no print failures due to ill-supported areas. Now, this is a great time also to use our tool that we talked about over here, this support blocker tool. Let's just say, if I went in the preview menu, let's say I don't think I really need any support to happen here. It's just going to waste filament. This little broken horn doesn't need it. I can go into the prepare menu, select my model like I have, select my model, select support blocker, and I can start dropping these cubes. And these cubes overlap or intersect with our model. And wherever they overlap or intersect, no support will be placed there. Now, as you'll see right here, I want to get it underneath all this red portion, because anywhere that's red, our support's going to try and support. However, with these bottom ones, I'm also blocking off this area of the rim, which I know obviously needs support. So what can I do? Well, these cubes can be acted upon like any other model. If I click one of these cubes, I can click the move tool and I can move it either along all three axes, or I can free move it all the way off. So I'm not worrying about it touching anything else. So it's a great way to kind of just adjust this and make sure that the areas that I don't need support aren't supported, and the areas that I do are supported. So now if I was to slice this, which I will, you're going to see we're going to have a normal amount of support everywhere, and this horn will not be supported. And that's great for saving us time and saving us filament. Our model is sliced. Enter the preview tab, and let's see what it looks like. All right, just like we wanted. The entire model has been supported. Oh, clearly I missed a section here, but the entire model has been supported except for this broken horn, which we know doesn't need support. So that's how those support blockers work. Now let's go back to prepare. Now what if we didn't want, and I'm going to use this object list to just get rid of all these at once. What if we didn't want all these erasers or these support blockers? What if we just wanted one, because they look kind of cruddy when there's so many? Well, like I said, we can affect this support blocker like we do anything else. I can scale this really big, creating just a single support blocker, and then just drag it up. And that will do the same exact thing as all those other smaller support blockers I put on there. I don't have to worry about it touching anything else, because nothing else over here is getting supported. Just this that I don't want to get supported. So that's just another option we have when using those support blockers. Now, I also can change the support structure. What we just saw was normal support. We also have the option of tree support, and tree support is really cool. Let's slice this, and what tree support does, it almost looks like the branches of a tree. It can support models in ways normal supports cannot. It can branch and arc over different sections of our model and support them without ever having touched them. It's really, really cool. And the best part of it, it's very thin. These supports are, I believe, a single layer around. It saves filament, and in general, it prints quicker because we don't have to go through the scaffolding system every layer like we do with normal supports. The one downside is it takes about double the time to slice our models. Let's take a look at our sliced model with tree supports. And it looks kind of similar to the normal supports, except right here you can even see some of these like branchy sections, and that's why they're labeled tree supports. This model doesn't require too many crazy support structures, but the branchiness of this really helps bend around and support different sections of models that normally wouldn't be able to. So I recommend trying both of these different support options. I really, really like tree supports. I found them to be nothing but positive, except for, of course, almost double the slicing time. But even on really big prints, like a Mandalorian helmet or something like that, the tree supports really pay off in a great way. Now, quickly, right before we leave this support section, I just want to show you how Cura will figure out where your model needs supports. And it's right here at the support overhang angle. Any part of the model that's more than 45 degrees will require support. That is because that's what we have here, 45. That's a great default. But if you have really tuned your profile or your printer, and you know, for instance, 65 is where you can go up to, you can click 65. You can change the support angle, and you'll notice right here, the red that was underneath here or even here is gone. So now your printer will attempt to only support these sections here. So if I was to slice it, preview this model with the higher support overhang angle, and you'll see nothing has been placed here. Minimal supports are being placed on the front, only right here. So there's obviously a lot of features we can tweak within the supports. Now, when we get to adhesion, I'm going to bring back the good old PL3D cube. And we'll look at build plate adhesion. Let's drop that down. Now the three settings we see here are type, line count, and distance. So when we look at build plate adhesion type, we have three options: skirt, brim, and raft. We can also choose to have nothing there. So let's look at the skirt first. If I have skirt selected and I slice it, go into the preview menu, this blue section right here is a skirt. It actually provides 0 adhesion capabilities. It does nothing to adhere our print to the bed. Really, its only job is to purge the nozzle. So let's go to that layer. We'll see the skirt is the first thing to print. So it's going to purge our nozzle. And if you've watched my bed level Z offset video or some of my other setup printer videos, which I recommend you do, especially if you're new, I use this skirt to kind of check adhesion by rolling my finger over it as it's printing, and I can see how well it's sticking to the bed. Other than that, this skirt offers no adhesive capabilities at all. Let's go to the next one, brim. Brim is an excellent way to improve adhesion. Let's slice it and look. What brim's going to do, it's going to have a width, 8 millimeters, and a line count. There is a 20 line count of perimeter outside of this model, and you can see it right here. So this is how the model is going to look when it's finally finished printing, and this area right out here is the brim. The blue is a helper, and this is, in this one in particular, it's a brim. And you can see how this might help adhesion, because what it's doing is it's expanding the surface area of our first layer, especially if you have supports. Whenever I'm supporting those big helmets or even that Sylvie crown we just saw, not only will I enable supports for that model because I'm going to need it, but I'll also enable a brim, and the brim will even go under the support, so all the sections of the model are being held very tightly to the build plate. So this is a really great way to achieve extra adhesion. The one downside to the brim, besides the filament that it's going to use, obviously, is sometimes it can get so close to this bottom layer, you might actually have a little bit of extra filament stuck there. So after you peel this off the build plate, you peel the brim off, you might have to go around here with a clipper and just take off a few extra millimeters of filament just to clean everything up. But brim is a great option. And the last option for adhesion is a raft. And a raft is excellent. What a raft does is raises our print off the build plate. I don't know what happened here. It's probably where I was when I sliced it last, right? Cura has some inherent issues, but for the most part, it is awesome. So this raft raises our print off the build plate. Really, really cool. This section right here is the raft. It's a bottom layer, and these gaps are here on purpose. They want airflow in between here. Then we have another layer on top, 2 top layers, and then our print prints directly onto this. So it's printing PLA on PLA. So the adhesion should be very, very good. Now what this raft is also going to do is going to prevent warpage. If you're having really bad warpage issues, this raft should alleviate a ton of those, because the raft itself is sealed to this build plate as best as possible. It's got a bottom layer, it's got air that's trapping it in there, and it's got 2 top layers. And then this model is being printed in the same material, PLA, on top. So that adhesion should be really fine. Now below any of our adhesion type, those are just different settings that affect those. For instance, skirt line count is 3 and the distance is 10. And now you'll notice these outer gray edges. What that's showing us is that's the bounds of our build plate based on our adhesion type. It needs to make sure that it can print a skirt around this object within these settings parameters. So let's say I change this from 10 millimeters to 1. You'll see this gray area is nearly non-existent because it needs to make sure that I can print this model all the way over here and still print a skirt around it based on this. Now, all these other options below here are really nothing we need to worry about. The only other things I would talk about that are contained within these menus, I'm actually going to use this search function up here. If I ever talk about something in Cura, or you hear someone talk about something and you can't find it in these drop downs, go ahead and use this search function. It's really convenient. 2 things I'm going to talk about. One is coasting. Coasting is going to be found under experimental. What coasting does is it replaces the last end of a line, of an extrusion line, with a simple travel pass. This is the final line of this outer wall. Normally it would print to the end, it would retract and move on. What coasting does is it prints the wall like normal, right till almost near the end. Then it lets whatever built up filament is in the nozzle ooze out to continue or to finish off that line, and then it moves on. Now this helps if you're getting some zits or some bulges right at the end of your lines. Coasting is a great way to alleviate that. All you do is enable coasting by checking the box, and I would recommend leaving all these settings as is. They're great for a 0.4 millimeter nozzle. For the final print setting, I'm going to bring in an appropriate model. I have downloaded this extension from the marketplace. I believe it's called Calibration Shapes. Lets me just drop down some shapes here. And right here we have a cylinder. I'm going to show you what is called, or what is commonly referred to as Vase mode. It is actually called Spiralized Outer Contour, and it apparently is in this pagan symboled menu. So Spiralized Outer Contour, instead of printing this cylinder as is, which is with infill, with a top and a bottom layer, it's going to print this all as one extrusion travel. So let's go here. It's not going to have any starts or any stops. After it finishes this layer, it's just going to go on to the next layer. You'll notice there's really no Z seam here because there is no starts and there is no stops. The reason it's called vase mode, you'll also notice no top to this. The reason it's called vase mode is because if you are to print a vase, this would be the most or the nicest way to print it, because there's going to be as little artifacts as possible, because this prints as a single extrusion path. Now those two settings we can talk about in a further video. I have a lot I want to go over in Cura. There are some really, really cool things we can do by using the support blocker, orienting models, getting different big models or helmets up and supported properly. I want to do all those things, but I really wanted to start with this.
Now, having gone through part 1 and part 2 of our introduction to Ultimaker Cura, you can now go out there to Cura, import some models, adjust some of those printer settings, and see how they affect your final model. Now, I recommend just exploring Ultimaker Cura and all those options we went through. There was a plethora, and they all can affect our models in a different way. Layer height, line width, messing around with supports. Now, all those topics can be covered in depth, trust me, and guess what? We're going to do it. Now, though, we have a great base to work on. Now, please, if you're running into any problems, nothing is too minor to ask a question down below. An issue you're having, I guarantee somewhere around the globe is having the same issue. And if they can come to my video and get an answer from the comments section without having to watch anything, well, then you're helping out just as much as I am. And I thank you. If you like this video, if you've seen some of my other videos, please subscribe to the channel. You'll be kept up to date with any different video I have coming out. You'll be notified. You can also like the video. That helps some of the back-end metrics, lets me know what's working, what's not working, so I can kind of adjust. As far as subscription goes and what's going on down the pipeline, got a lot of great ideas. Very soon I'll be doing a nozzle video. We're going to go in depth on our nozzle, the diameter, layer height, line width. We're going to ultimately replace the nozzle, so we'll look into that. Then I bought a bunch of bimetal heat breaks. We're going to upgrade our stock hot end to an all-metal hot end that is capable of printing high-temperature filaments, ABS, PETG, TPU, all while not worrying about off-gassing harmful chemicals because our Bowden tube is too close to our nozzle. So that's a really great, very beneficial video. And I just bought a direct drive hot end. I have to put it on one of these printers. I don't know which one I'm going to do yet. I'm thinking it's the Aquila, but it's up in the air. So if there's a particular model of printer you want to see me install this direct drive hot end, this whole unit, so please leave a comment down below and I'll see if I can make a video just on that. So thank you once again for staying this long, and as always, until next time, boys, girls, everyone else, keep on printing.